Yes, as introduced, I'm Kwangho Choi from AhnLab CloudMate. I'll begin the presentation. The title is a bit grandiose. The title, The Evolution of Security Protecting Enterprises in the Era of AI, does sound a bit grand, but I'm going to break it down and talk about it in a simpler and more approachable way. I thought about an example. To make things easier, I thought of an example, my own name. Of course, to improve the quality of my documents, I upload project reports to ChatGPT. But without realizing it, things like APIs or credentials embedded in the dashboard could end up included in those documents. When that happens, as soon as the content is sent to ChatGPT, it doesn't show me any warnings about what's included. And I don't get any special notifications about any policy violations either, because I was just using it on the internet, that's all. After that, our security team has no way of knowing where it went, and I also have no idea how it moves around once it's inside. There's just no visibility at all. Fortunately, most of the time nothing happens and things just pass by without any issues. But if there really is no problem, then that's fine. However, a few weeks later, these credentials could end up being leaked on a dark web forum. And once they're out there, a cybercriminal could buy them, use them to break into our system, authenticate themselves, and gain access. That's the kind of thing that can happen. This might sound like an extreme case, but it's actually something that can happen quite easily. So, what is the main foundation behind these kinds of incidents? We believe it's shadow AI. You can think of it as a term that comes from shadow IT. So, what is shadow AI? It's when AI-based tools are used within an organization without explicit approval or security oversight. So, have you ever thought about this? You might be using ChatGPT within your organization, but are you really able to monitor exactly how ChatGPT is being used in your organization? Are you absolutely sure about it? Are you? Unfortunately, I have never met a single customer so far who could answer the question I just asked. What this means is that about 90% of the AI tools you're using, including ChatGPT, are already being used as shadow AI within your organization. We tried modeling it. So, we modeled how shadow AI is used, how information leaks, and how it moves within the organization. First, you start by entering a prompt. When you use AI, you end up using prompts, right? When entering prompts, of course, people who are highly aware of security will naturally think, this isn't allowed. But for most people, that might not be the case. Through such prompts, there is also a possibility that various passwords or secret keys could be leaked. Ultimately, these prompts end up being logged through the LLM and sent over to the provider. Now, there are probably developers and architects here, and if you've built a system, it's only natural that logs for that system are generated. Even if the logged information isn't made public, it will still be logged. Of course, that information won't be officially disclosed. However, whether due to a mistake, a problem, or even a policy, the logged information could end up being exposed. But there can be situations where the information that's been made public, the log data, or even captured content in the middle gets exposed to the outside. In these exposure situations, the keys or other important information I mentioned earlier can end up being discovered by outsiders. And what gets discovered ultimately leads to a leak, and that leak can have a significant impact on the organization. So, in the end, everything can happen through these kinds of patterns. Now, the cases I've talked about so far are pretty extreme examples. Why do these kinds of cases happen? I'll give it some thought. In our opinion, the first reason is that we use a lot of distributed AI services. AI services are being used in a fragmented way. There isn't a unified AI service channel. For now, since it's still shadow AI, everyone is using it freely. Because of that, we don't even know where or what kind of AI is being used, and we have no idea what policies to apply to those AIs. We need to be able to see them in order to control them, and only if we can control them can we prevent problems. But right now, we're not even able to see what's going on. Another thing is that AI doesn't operate alone anymore. We've moved beyond the LLM stage and are now heading toward agent AI. That means multiple AI agents are coming together, communicating with each other, and acting together. In other words, the speed and responsiveness in the AI world have already surpassed the level that humans can judge or keep up with. So, how can we possibly control these things? In the end, All of these issues can be grouped under the term security blind spots. As these security blind spots increase, the kinds of threats I mentioned earlier also grow. According to our statistics, about 8.5% of prompts currently used with LLMs already contain confidential or sensitive information. Moreover, OWASP has already released not just a list for web applications, but also a top 10 specifically for LLM applications. In particular, about 5 of the items shown here are, in our view, vulnerabilities and threats related to data and prompt input-output. These are issues we need to focus on, and regulations are already being put in place for each of them, one by one. So, does that mean governments are just sitting back and doing nothing about these regulations? That's not the case. So, in the end, what kind of regulation is this? We can't say for sure just yet, but still, since using AI means using data, it is subject to existing network laws and various regulations related to data. In addition, various agencies, like the National Intelligence Service, the Personal Information Protection Commission, and the Korea Communications Commission, have already released and distributed relevant guidelines. This means that for companies, organizations, and institutions, it's becoming clearer step by step what they will need to do going forward. I'd like to talk about N2SF now. I'm not discussing N2SF in detail. Since N2SF reflects changes in network separation policy for public institutions companies think that doesn't apply to them. What I want to emphasize about N2SF is this. N2SF moves away from traditional perimeter-based network separation, instead categorizing data into open, sensitive, and classified types. The idea is to open up what can be shared so that internet SaaS can be used, assess what's sensitive, and fully protect what's classified. In this case, the person responsible for making those decisions will ultimately be the data owner, but it also raises the question of how to verify whether those decisions were made correctly. It's right for the data creator to decide what can be opened, but was what was actually opened appropriate? Could sensitive data have been leaked? Or something that should have been classified got leaked? This means that companies or organizations need to have evidence or audit materials prepared for this. But as I mentioned earlier, what about us? We don't have any visibility at all. In addition to MITRE and OWASP, which I mentioned earlier, there are also frameworks like MITRE's Atlas framework and Finos' framework. And even in the list we always look to as unchanging truths, RMF is included. And ISO standards have already been established as well. There are standards related to AI, and certification projects have already begun. In the case of the EU, regulation has already begun with the AI Act. What this means is that all the things I've mentioned so far are coming together, and as a result, the situation we need to prepare for is approaching. Now, in this situation, there's another factor that's making these regulatory circumstances even riskier and more complex, and that's agentic AI. Agentic AI, which I've been talking about so far, is rapidly evolving in this direction. Especially when it comes to agentic AI, interest has skyrocketed, with search volume doubling in the first half of this year alone. We've identified 5 major risk factors associated with this kind of agentic AI. The first risk is unpredictable behavior, followed by the leakage of sensitive information and external APIs. This is because agentic AI allows agents to exchange APIs with each other without human control. If we can't precisely control the authorized APIs here, we won't be able to know what kind of data is being transferred within them. Next, there's the exposure of PI or sensitive information in the data, and then excessive permissions. Especially in retrieval-augmented generation, RAG systems that use vector databases, the traditional role-based access control we used to have often doesn't work properly. When you build a RAG system using a vector database, it's actually much more effective to convert a lot of the company's internal data into a RAG format for optimal results. But the problem is, when you convert that much data into a RAG format, the access controls for that data can break down. That's because you can't manage user permissions for those who use the RAG system. So, as vector databases are created and more data is converted into RAG, managing permissions becomes even more challenging. And then, security policies are no longer enforced centrally. That's why, as I mentioned earlier, it's already invisible to us, so deploying policies is out of the question. These are the biggest risk factors in agentic AI. The question is whether we can control these with traditional security methods or conventional security measures, and the answer is that it's not easy. In the same vein, based on this, what used to be called guardrails, models that protected our LLMs, are now evolving into the concept of a guardian agent. A guardian agent is a multi-agent system that secures security and observation, performs filtering, and has monitoring capabilities. Additionally, it should also be able to handle routing for LMs and orchestrate agents. This is the concept they are proposing. They say there are three main factors included in a guardian agent. The first is observation. Observation is necessary, in other words, between agents and agents. You need to be able to observe what is happening between agents. The second is evaluation. You need to be able to assess what the actions between agents mean or whether the agent is acting in line with the AI's intended purpose and goals. Then, based on the results of observation and evaluation, you should be able to intervene as needed. Does this look like my face? I tried drawing it. So, why do we need a guardian agent in this process? Ultimately, as I've been saying, the first reason is a lack of trust. With the increasing use of AI, or MAI, or ML, the first question is whether we can really trust them. Next, following the question of whether we can trust them, is the issue of increasing autonomy, as AI and ML gain more autonomy. The second question is whether we have the authority or systems in place to control that autonomy. Can we respond quickly enough to the rapid spread? As I mentioned, we've hit the limits of human capability. Now, as things move beyond human control, with communication and action solely between AI agents, can we truly control them? This is where we've hit our limits. These issues highlight the need for AI agents, specifically guardian agents that can be controlled. Guardian agents can be broadly divided into three main types. The first type is the reviewer. A reviewer is responsible for verifying the accuracy of the results and content generated by AI, and for determining whether the data used is permitted, like the authorized data I mentioned earlier in N2SFS. The reviewer must be able to identify and assess the scope of use for such data. Next, there's the monitor. The monitor's role is to constantly observe, in real time, the interactions and data exchanges between agents and humans or between agents themselves. This monitoring function is essential. Then, there's the protector. The protector function is about blocking and controlling actions when an agent or a human deviates from established rules, based on the actions identified by the previous two functions. These three functions, reviewer, monitor, and protector, are considered the main types of guardian agents. So what functions must these guardian agents have? Real-time monitoring are essential to observe communication and movement between agents, and between humans and agents. Real-time agent is a must. As mentioned earlier, the ability to detect and block policy violations is essential. Next is auditing actions and logging. Auditing actions and logs will ultimately become a fundamental function of the AI guardian agent. After that, there may be a need for features that can trigger based on risk scores and quantify and manage threats using those risk scores. Lastly, features that support compliance and ethical regulations, how to ensure adherence, will become key functionalities. So, will these guardian agents just be a single model? That's not the case. There are mainly three areas where we use AI. We use AI at the model level. Simply put, we use foundation models like ChatGPT. Then, to use this model, we use applications. The ChatGPT web that you all use is the ChatGPT web application. When we send a prompt through that web application, it connects with the model on the back end. So, this application exists. Besides that, there are also various other products. These are connected to the model, and then, as I mentioned earlier, there will be AI agents, not just ones that communicate directly with people like us, but also AI agents that perform tasks autonomously. So, you can think of these three entities as the main entities that use AI. For each of these AI entities, the role of the guardian agent can be a little different. First, when it comes to the AI guardian agent related to the AI model, its main role is ultimately to check for model drift, to determine whether model drift is occurring or not. That would be its primary purpose. Generally, when we talk about model drift, it means the model is behaving in a way that deviates from its original purpose. So, the role here is to check for that. If the model starts to stray from its intended purpose, performance, or functionality, then it needs to be monitored, corrected, and adjusted. Real-time monitoring for these kinds of issues is a key function required for the main model entity. For AI applications, the main functions are likely to be context-based access control or dynamic control. That might sound complicated, But basically, it means we need to constantly monitor, block, and control whether prompts we use are being leaked, whether important information is being exposed, and so on. Next, for AI agents, you need to check for drift between agents. That is, whether the agents are deviating from the goals set during their design. Also, you need to monitor their activities for security. You might think, wow, with AI agents, life is going to be so much better and more convenient. But just imagine, for example, that you have an agent that plans your vacation for you. Now, imagine if everyone in the country used that kind of agent. If you want your vacation plan to be carried out perfectly, that agent would also need to make payments for you. For the agent to make payments, it would need to have access to my payment system information. So the question is, can we really assume that the agent will perform its role properly? We need to be able to monitor whether the agent is acting according to its intended purpose. So, can we build these guardian agents from the beginning? The answer is no. We must proceed step by step. In the first stage, we need to consider issues arising during development. First, we need to start by checking, taking action on, and logging user inputs, AI responses, and prompts. By monitoring for things like basic PI or sensitive information exposure and malicious responses, we can practically prepare for the next phase in the era of agentic AI, where AI agents communicate with each other. However, at the maturity stage, unlike the earlier development phases where the focus was on user input or LN applications, the main objective becomes the control of the AI agent itself. When that happens, we need to move toward a system that can monitor whether the agent has been given excessive authority and whether it is acting appropriately within its proper permissions. We are now beginning the development phase. In the development phase, the initial setup must be completed first, and after the development phase is finished and the system is in use, we should then consider the elements of the maturity phase. We believe this is the flow we need to follow. As an answer to this, what we at AhnLab CloudMate offer is a solution called CQO Bridge. To put it simply, CQO Bridge is the best way to safely use the LLMs you are currently using, and I want to emphasize that as a premise. Even if you use it as you normally would in your browser, everything is logged, and if necessary, it can be blocked or controlled according to central policy guidelines. Let me explain in a bit more detail. CQO Bridge has data protect features. An LLM-based engine detects and blocks data input-output. It also has prompt monitoring capabilities. You can check prompt history to determine normal or abnormal. Lastly, features distributed and managed as a unified policy the entire organization. Broadly speaking, the functions can be divided into user features and admin features. User features include PI and SI detection, CI detection, and prompt injection prevention. Let me explain in more detail. First, PII and SI detection. This refers to personal information. What you see on the left is before applying the feature, and what you see on the right is after it's applied. The information you see on the left gets blocked, as shown on the right. But isn't this something Guardrails already does? When it happens in Guardrails, it means that the data has already been sent to the LLM. It gets sent to the LLM and is blocked there. But if you build our system, you can block that data within our network boundary. Next is pseudonymization and anonymization. You use this often, right? On LLMs, people ask to organize such data. In these cases, we can process personal info by pseudonymizing or anonymizing it on our side. As you can see, info like real names is processed and sent out pseudonymized. Of course, anonymization is also possible, and naturally, blocking can be done at the file level as well. When regular files are uploaded, and when confidential information files are installed on our system, a blocking window like this will pop up to prevent access. This red UI is just the default interface provided by ChatGPT. The reason this is important is because, in the security field, one thing we security folks used to say was that we could do everything, but we don't say that anymore. Now, we're more humble and focus on how we can enhance security without interfering with the user's business. What that means is, it's extremely important to maintain security without disrupting the user's UX environment, allowing users to keep using the interface they're familiar with. Our solution does not compromise the user's UX environment. Without disrupting it, we use the same UI provided by ChatGPT or Copilot to carry out these blocking actions. This part here is about code within CI detection. If information like tokens or license detections, which can easily be included in CI, are found, they will be blocked. CI is a bit different because CI refers to a company's confidential information. So, in the end, if candidate Kim Young or any company, including ours, claims that they can know and block that confidential information, then it's no longer confidential. At that point, it's public information. Only the company should know it's confidential information. Saying a web solution can block a company's confidential information is only half true and half false. So what should we do? Ultimately, companies need to be able to easily create blocking models or patterns related to their confidential information within the company itself. What we, as third-party vendors, need to do is to provide a pipeline that makes it easy for companies to create models that can block or embed their confidential information. At SecuBridge, we have built an internal pipeline that allows companies to easily model their confidential information. Next is prompt injection. This refers to blocking scripts that are created with malicious intent, such as scripts designed to harm a company's reputation or perform harmful actions within the company. Similarly, it's about preventing things that could damage a company's reputation. These are some of the features we offer. Let's take a quick look at the video. Let's briefly review what we've seen so far. You can see how the code is detected here. There are two main points I want to make. First, we don't require you to install any separate applications. There's no need to install a separate application or access a different URL. You can just keep using the same UI and UX environment you're already familiar with. There's no need to install any agents either. The second point is something many of you are concerned about. Isn't there a latency issue? Take a look. There is no latency issue. Why isn't latency a problem? Because we're already using ChatGPT and dealing with its latency. Since we're already dealing with that, the 0.1 microsecond or millisecond level latency added by security products doesn't actually affect the user experience. So, you really don't need to worry about latency at all. If you look here, this is the kind of report you'll see. These typical reports are summarized well, right? Of course, standard reports will be summarized just fine. But when it comes to reports that contain personal information or sensitive data, those shouldn't be allowed to leave the system. Let's take a look at those kinds of cases. These are reports that contain personal information. When you try to export these kinds of files, they are immediately blocked. The system reads the file and checks it internally. It's not just based on the file extension. However, as I mentioned earlier, the UI can be a bit unfriendly in these cases. For that, we provide a separate extension. If you use this separate extension, the UI becomes much more user-friendly. Sorry, I mean it changes to a more user-friendly UI. The video also demonstrates that these kinds of things are possible. Let's move on. Next is the admin feature. There are three main things I want to talk about regarding the admin features. The first is how you can check the various report histories that I've mentioned so far. Of course, this should be possible. The second is whether these things can be distributed as a centralized policy, which is important. The third is whether these actions, our actions, or the activities of security administrators, are being audited so they can be used for audits. That's what this is about. Let's take a quick look. Prompt history confirmation. I'll show you a video. As you can see, you can view logs and everything exchanged in prompts. You see everything, and it's set up so who sent what, when, and from which IP are logged. So, ultimately, you can decide later whether to block something or not. But first, it's important to secure visibility. It's important to first secure visibility, review what you see, and then determine whether something needs to be blocked. So, I think it's right to focus on securing visibility first. Next is the edge part, and this is actually one of the special features that only we have. In our view, generative AI like ChatGPT is used by all employees. When all employees use it, everything they do gets logged together. As a result, prompts and data used by key C-level executives and those used by regular employees all get collected in one place. From a security manager's perspective, this can lead to situations where they end up seeing information they shouldn't or aren't supposed to access. One of the easiest ways to overcome this is the method we propose, creating a separate channel in isolation. We set up a separate edge for C-levels or for specific roles. Or we can create an edge for general roles, so that each user is logged and managed through a separate channel. You can easily create the related edge for that purpose. Since we also run an MSP business by default, the edge runs as a pod based on Kubernetes. When you create it here, you can easily generate the edge right away. Next, let's talk about the supported LLMs. The currently supported LLMs are the ones listed here. We support these LLMs, and in addition to these, Grok and the last one, Claude, are expected to be completed by the end of this month. We plan to add those as well. For LLMs with high market share, we do not charge any additional fees. There are no extra charges, and the LLMs will continue to be updated according to our updates. You can simply turn them on or off, and you'll be able to block and log the LLM content right away. Next, all user information and application usage within this application will be continuously audit logged, so you can use these logs later when you need to load them. Let's take a look at the video for this as well. This is about the prompt history section. As you can see, you can of course view all prompts or filter them by IP address. If you look at the detection results, everything is organized and categorized by whether it's normal, whether personal information was detected, whether confidential information was detected, or whether there was a prompt violation. If you click on a specific item, you'll see below which user sent it from which IP, when that user accessed the system, what query was sent, why it was blocked, and what return value we provided. All of this is recorded. Of course, you can also download this data separately as an Excel file. It's organized in this way. The audit log is a feature that exists within our application. I'll move through this part a bit quickly. You can see how different features operate in various applications, and this is what I mentioned earlier as the edge. You create a separate isolated channel, essentially establishing a dedicated pathway on a separate edge. This allows for effective management. By assigning permissions for each edge, only authorized users can access the edge, which is a way to mitigate risks that could arise from such logs. You can set it up like this. As you can see here, you can set policies separately for each edge. You can also specify which LREC to view. And since you can set separate policies for each edge, you can apply RBAC individually to each person included in the edge. I'll skip over this part. In the end, there are three main benefits we expect from this product. The first is to prevent data leaks through generative AI data and AI services. The second is to ensure transparency in AI usage and to establish a foundation for internal controls. As I mentioned at the beginning, securing visibility is the primary reason. Lastly, it's about strengthening our ability to respond to regulatory compliance. Ultimately, these are things we need to do and prepare for, so we believe you can get ready in advance and check these matters ahead of time through us. Now let's dig a little deeper and show you more of what's inside. Basically, we have three core engines. The first is the prompt injection prevention engine. When we say we detect prompt injection, it means it's not just pattern recognition. Because we need to be able to block context-based prompt injection, we have an SLLM built in. We also have a separate small LLM. We use this small LLM to block prompt injection. Of course, does it have the same level of context awareness as the foundation models provided by big tech companies? No, it doesn't. It can't reach that level, and our infrastructure isn't as powerful either, so it's just not possible. However, we believe that it can sufficiently recognize prompt-based attacks or issues that may arise when using LLMs in general. Next, there's PI and SI. The fastest way to handle this is with regular expressions. Since the patterns are clear, and the data here has clear patterns, the fastest way is regular expressions. However, there are a few issues when applying regular expressions. It's fast, but it can lead to overdetection. It's also fast, but it can result in false positives. Again, it's fast, but it can also result in misdetections. To prevent this, we added two more engines. So, beneath the regular expression engine, there's a dictionary-based engine. The dictionary-based engine helps prevent misdetections, or it allows customers to double-check specific patterns of data they want. Lastly, we have our own patented engine layer that uses SLM to review the context one more time, correcting any false positives or false negatives that may occur. The final one is the CI engine. As for the CI engine, I mentioned it briefly earlier, but the most important thing about the CI engine isn't just its performance. What matters even more is whether there's a pipeline that can make the CI engine highly customized for each customer. In the end, the CI engine should only exist internally. The moment you say that can be done externally, I've already mentioned that it's no longer CI. That's public information. So what's really important is how easily you can model the internal CI and reflect it in the engine, and whether you can provide this pipeline. That's what I emphasized. So we provide this pipeline for you. If you're wondering what a simple pipeline is, it's basically just files. You upload the files to a specific directory, and we make sure our pipeline is always running. Then, the tools in our pipeline read those files and use them to train our model. After training, you'll end up with a final model. And if you update our internal engine with that model, from then on, you'll be able to block CI that's specifically tailored to your institution, organization, or company. That's how we provide the CI engine. Of course, even if you don't use the CI engine internally, we still provide basic CI blocking. For example, things like license information or key values being leaked, as you saw earlier, are considered general cases, and we block them. But let's say you need to block something like Samsung Electronics blueprints. We have no way of knowing what those blueprints are. So, if it's those blueprints, you can train a model with the blueprints that Samsung Electronics considers important and apply it. And from then on, it will block content specific to Samsung Electronics. This is how the service flow works. As I mentioned earlier, with our product, you don't need to install any separate agents. And you also don't need to install any separate extensions. Plus, there are no additional network configuration difficulties. So, users can just make requests in their browser as they normally would. Then, depending on our technology, if the request is for an LLM, it will be sent to us. We then separate it into prompts and files. After splitting into prompts and files, we filter the relevant content, and if we determine it's safe, we send it to the LLM. If not, we perform detection. Of course, if certain conditions are not met, it may be necessary to install a separate extension. Or, if some specific conditions aren't met, a separate agent might be required. However, in most cases, you don't need an agent or an extension, and that's our biggest advantage. This can also be considered another advantage. From a security administrator's perspective, the biggest concern when adopting a new product is the footprint. When a failure occurs and all the issues come directly to you, as a security manager, you wouldn't want to use that solution. But one of our features is that we only handle traffic related to LLMs. So, even in the worst case scenario where our solution fails, only the services related to LLMs would be affected, or, depending on the architecture we apply, recovery can take place. In the worst case, users would just use LLMs without any controls, as they did before. This means the impact on external business that security managers have to bear is much lower. That's one of our strengths. I think this is the last main part. The differentiation points are really a summary of everything I've mentioned so far. First of all, the biggest differentiator for SECU Bridge is that we support a wide range of infrastructure environments. By various infrastructure environments, I mean that we support SaaS models as well. And we also support managed SaaS models. We also support on-premises deployment. And if there are separately managed cloud zones, we support installation in those cloud zones as well. In other words, our solution can be configured in almost any infrastructure environment. For example, we have a particular customer who is deploying in a completely closed network environment using Nutanix, and that's currently underway as well. There are also customers who want to use our solution entirely as SaaS in the cloud. And for some customers, like large conglomerates, they operate their own dedicated cloud zones. In such cases, some customers ask us to set up a managed cloud zone on our cloud. All of these options are available flexibly. However, as I mentioned earlier, if you use our SaaS, the CI feature will be excluded. That's because the moment our SaaS accesses a company's CI, it becomes PI. The second advantage is the agentless method. As I mentioned earlier, there's no need to install an agent. There's no need to install any separate application. As far as I know, there are many solutions similar to ours, but most of them require installing an agent, setting up separate equipment, or installing some kind of extension. The fact that none of those things are necessary, I think, hides an inner advantage here. Let's assume the perspective of a customer security manager. From the security manager's point of view, most of the people they work with are actually customers. If you tell these customers, you have to install an agent, or you can only access the LLM through a specific application, what do you think the customers will do? They'll start looking for ways to use it without having to do that. And that, in turn, could actually increase the attack surface within the company. Another major advantage of our approach is that it isn't tied to any specific network segment. For example, in the most basic case using our method, if you have a setup that requires certain network equipment, you can enforce controls once you're outside that network. For instance, if someone uses a different internet network in another room or accesses the internet from home, you can't control whether they're following the rules. But if you use our method, no matter where someone is or what internet connection they're using, we can enforce controls in the same way. That's one of the advantages. Lastly, there's multi-LRM. As I mentioned earlier, we support all the LRMs that we believe are the most effective in the market and have the highest market share. In my opinion, by the end of this year, we will probably cover about 90% of the most widely used models in the entire foundation model market that you all know. Besides that, according to Jose and AMP, thank you, there are about 100 applications related to LLMs or ZenAI in the market, domestically and globally. Although we didn't conduct this research ourselves, according to a study by MS, there seem to be about 300 such applications. But putting the global market aside for now, among the roughly 100 applications available domestically, we can of course control a certain portion of them. And for some of them, logging is possible. By logging, I don't mean logging the specific prompts, but at the very least, we can see which users are using which LLMs. That's something we can check. So we can provide information about those things through logging as well. Can you see all 100 of them? No, that's not the case. That's not the case. But at the very least, we can provide an environment where you can monitor whether this user or our internal team members are using these things, instead of being completely in the dark as before. I went through things a bit quickly, so I'm not sure if you were able to catch everything, but I think I've covered all the points I wanted to make. The biggest problem with generative AI right now is the lack of visibility. I think everyone would agree with that. To address that, you'll need a solution like ours. We're not an all-in-one tool that can do everything, but we believe we can serve as one layer in a multi-layered defense system. Databases already have multi-layered defense systems, and so do networks. But in LLM environments or generative AI environments, there isn't a multi-layered defense system in place. As the first layer in such a defense system, AhnLab CloudMate's Secure Bridge can play a significant role.